Let's talk about calculating your index of hydrogen deficiency or your degrees of unsaturation for molecules that contain um, atoms or elements from group 6, for example, oxygen or sulfur. So what you do is nothing. C5H8O, for example. So if you're asked to calculate the index of hydrogen deficiency for this molecule, you do not add or subtract, right, anything from the number of hydrogens in the unknown. So for oxygen, do nothing. Okay? Unlike halogen, remember we add oxygen, do nothing. Okay? If you want a little cute little way to remember that, remember the word nothing has a O in it. Just use that for your oxygen. Okay? So do nothing. So let's talk about how we would calculate the index of hydrogen efficiency for this. It's hydrogen in your reference minus the number of hydrogens in your unknown, right? Divided by 2. So number of hydrogens in my reference, my unknown has 5 carbons, right? So remember your reference comes from CnH2n plus 2, your alkane, with the corresponding number of carbons as in your unknown. Okay, so I need to write my alkane with 5 carbons. An alkane with 5 carbons has 12 hydrogens. 5 times 2 is 10 plus 2 is 12. So this is 12. Number of hydrogens in my unknown is the molecule that they gave me, right? This is the unknown because I don't know what the structure of this is and I don't know what the index of hydrogen efficiency is. This is what they're asking me about. It has 8 hydrogens. That's all you have need to put here. Remember, do nothing for group 6. So this is going to be equal to 12 minus 8, which is 4, divided by 2 equal to 2, right? Let's look at another example before I explain why you do nothing for molecules that have oxygen contained in it. What if you're given C10H14 O and you're asked to calculate the index of hydrogen deficiency? You do the same thing. Hydrogen in your reference, which is the alkane, minus the number of hydrogens in the unknown, divided by 2. Number of hydrogens in my reference would be, find the number of carbons in the unknown. It's 10. So it means my reference will be the alkane with 10 carbons. 10 times 2 is 20 plus 2 H22. So this is 22 minus the number of hydrogens in my reference, which is 14. 22 minus 14 is equal to 8. Divide that by 2, 4, so I have 4. Let's talk about why we do nothing. So if you don't remember this explanation, you please to remember that for group 6, you do nothing, and group 6 starts with oxygen. Nothing. The O in nothing is your oxygen, all right? Let's let's talk about why we do nothing. Here's why. When you introduce oxygen into an existing hydrocarbon, the number of hydrogens does not change. Okay? So here I have my diene, right? My hydrocarbon molecular formula here is C5H10. Okay? If I introduce an oxygen here, notice the number of hydrogen is still the same. Number of hydrogen is still 8. So that's why you do nothing. You introducing the oxygen does not change the number of hydrogens. Remember when we introduced it for halogen, something different happened. So we had to do something. All right. Group 6, do nothing. Oxygen, we do nothing. Remember that.